Welcome to Raw Perfect classes. In this video, I will continue first order differential equation of higher order. Now next topic I will discuss, that is linear differential equation. Linear differential equation with variable coefficient. In this type of equation, first of all, consider linear differential equation with variable coefficients like ax square d square y over dx square plus bx dy over dx plus cy is equal to 0. Then putting log x equal to z, then equation 1 reduces to a d square y over dx square plus b dy over dx plus y equal to 0, and which is a linear equation with constant coefficient and which can be solved by this method. Now I am going to take one question. Solve x square d square y over dx square minus x dy over dx plus y equal to 0. First of all, putting log x equal to z, then the given equation reduces to in square bracket d bracket star d minus 1 minus d plus 1 bracket close y equal to 0, where d is equal to d over dz. And second equation you can write like this: m square minus 2m plus 1 equal to 0. M minus 1 whole square, that is equal to 0, because this formula will be a square minus 2ab plus b square. So that's why m minus 1 whole square, a square minus 2ab plus b square, that is equal to a minus b whole square, and you will get m is equal to 1 comma 1. How? You can see here, m minus 1 equal to 0, m is equal to 1 and m is equal to 1. Now next, write, hence the solution is y is equal to az plus b bracket close e raised to power z, because log x equal to z and x is equal to e raised to power z. y is equal to, in square bracket, a log x, a log x plus b, square bracket close, x. This is your answer. Thus we can solve linear equation with variable coefficient. Now next method, I am going to discuss next topic, that is related to partial differential equation. A partial differential equation is such type of equation in which includes one or more partial derivatives. The order of partial differential equation is that of derivative of highest order in equation. Partial differential equation may be formed by two methods. First is eliminating arbitrary constants, and second one is eliminating arbitrary functions. Now first, eliminating arbitrary constants. For example, you have given this equation, z is equal to x square plus a y square plus b. This equation is given and we have to implement partial equation by eliminating arbitrary constant. First of all, you have to differentiating partially with respect to x and y, and then we get derivative of z over derivative of x, that should be equal to p, and p is equal to 2x y square plus b. It means here we take derivative of x square plus a. We take derivative of x square plus a, and that should be equal to 2x. And y square plus b will be written as it. And second derivative of z over derivative of y is equal to q 2y and in bracket x square plus b a. That means we have to take derivative of y square plus b only. That should be equal to 2y. Now after this we will give this first equation and second equation, and now multiply one and second equation with each other. We will find PQ, that is equal to 4xy and x square plus a and y square plus b, that should be equal to 4xy z. This is solution of eliminating arbitrary constants. Now second is eliminating arbitrary functions. I will take here one example. If you have given z is equal to function of x square plus y square, eliminate the arbitrary function from z, function of x square plus y square. First of all, you have to differentiating partially with respect to x and y. Derivative of z of derivative of z over derivative x equal to f x square plus y square, that should be equal to, into 2x, and p is equal to f dash x square plus y square 2x, and that should be equal to f dash x square plus y square equal to p over 2x. This is first question. Second question will be derivative of z over derivative of y, that should be equal to f dash x square plus y square into 2y, means here we will take derivative of y square, and after that f dash x square plus y square into 2y, that should be written q is equal to, and after that f dash x square plus y square equal to q over 2y. This is second equation. Now eliminating f dash x square plus y square between first and second equation, and we get py is equal to qx. This is answer. Py is equal to qx. How? It should be p over 2x, that is equal to q over 2y, and p multiply by 2y equal to q 2x, 2 cut with 2, and py is equal to qx is your final answer. Now next method is partial equation, partial differential equation by direct integration. Now we will solve the partial differential equation by direct integration method. A partial differential equation can be solved by successive integration in all cases where the dependent variables occurs only in the partial derivatives. For example, we have given statement solve derivative of z with respect to x, that is equal to 0. This is given equation. First integrating with respect to x, and we get z is equal to function of y, and here f is arbitrary function. Arbitrary function. You can take another example. Solve derivative square z over derivative x square equal to xy. Integrating with respect to x, derivative z over derivative x equal to x square over 2y plus function of y. How we will get it? When we take integration of x into y, then you can see here x power 1 plus 1 over 1 plus 1, and y should be written as it, and x it will be x square over 2y and plus function of y. And f is arbitrary function. Here f is an arbitrary function. Now again integrating with respect to x. Now z is equal to integration of x square over 2y plus integration of plus fy. We will 1 by 2 into x cube plus divided by over 3 y plus x integration of this x y function of y plus phi of y, and it will be equal to x cube over 6y plus x function of y plus phi of y. This is answer. Now next topic is first order partial differential equation. First order partial differential equation. A solution of partial differential equation is a relation among independent and dependent variables. It's a solution of partial differential equation which shows a relation between independent and dependent variables, and which satisfies the partial differential equation. And there are three types of solutions. First is complete integral. Second one is general integral, and third one is singular. Now first is complete integral. Complete integral means the solution which include as many arbitrary constants as number of variables is called complete integral. And general integral means the solution which contains maximum possible number of arbitrary functions, that is known as general integral. And singular integral means differentiating complete integral, that is called a singular integral. Now I am going to discuss standard types. First standard is the partial differential equation is of the form function of PQ equal to 0. In this case, we will implement complete integral is z is equal to ax plus by plus c, and here a comma b comma c are constants. And from this is first equation, and from the from first equation p is equal to derivative of z with respect to derivative with respect to x, that should be equal to a, and q is equal to derivative of z with respect to y, that should be equal to b, and after that replacing p by a and q by b. In f of p comma q, that is equal to 0, and we get f of p a comma b equal to 0, and solving this for b, we get b is equal to phi of a. Thus z is equal to ax plus phi of a y plus c. It is complete integral where a and c are constants. Its rule is that first of all set p is equal to a, then q is equal to b in first step in given partial differential equation. Solve for b in terms of a and say b is equal to phi of a. After that, in second step, you have to write result dz is equal to p dx plus q dy, and we will get dz is equal to a dx plus phi a dy. In third step, integrate and get the complete integral. There are the three steps. In first step, step 1, right, set P is equal to A, Q is equal to B in partial differential equation, and B in terms of A, and say B is equal to phi of A. In second step, dz is equal to P dx plus Q dy, and we get dz is equal to A dx plus phi A of dy. In step 3, integrate this, and complete integral will be z is equal to ax plus phi of ay, and where a and c are arbitrary constant. Now I am taking one example, one question. Solve p square plus q square equal to npq. Now solve it. First of all, write this form: f of p comma q, that is equal to 0, and z is equal to ax plus vy plus c, and where a square plus b square equal to nab, or you can say a square plus b square minus nab equal to 0. And now put the discrimination formula: d is equal to b square minus 4ac, and after that you will find b is equal to minus, you will find x minus b plus minus d root square root d over 2a formula. You have to implement this, but in this we will write it like this: b is equal to na plus minus in square bracket n square b a square minus 4a square over 2, and a is common in bracket n plus minus in square bracket n square minus 4 over 2, and after that now from dz is equal to p dx plus q dy, dz is equal to a dx plus b dy, and is equal to a dx plus a over 2 n plus minus in square bracket n square minus 4 over bracket close dy, like this. After that, integrating, and we will get z is equal to integration of a dx plus a over 2 integration of n plus minus in square bracket n square minus 4 y plus c. dy. You will find its answer will be ax plus a over 2 n plus minus in square bracket n square minus 4 and dy's integration will be y plus c, and here a and c are arbitrary constants. You should keep in mind, when we integrate a, we will write a integration of 1, and 1's integration, that should be equal to 1. So that's why we will here write here x, this x, and this whole value will be constant, and we will take here 1 is it will be write like this, n square minus 4 integration of 1 dy, it will be written as it, and instead of this we will write y. So that's why we will write here y, and it will be written as it. Now next is general integral. In case general integral, we should be putting c is equal to g of a in the complete integral, and we get z is equal to ax plus a over 2 bracket start and plus minus in square bracket are n square minus 4 bracket close y plus, instead of writing c, we will write here g of a. This is a general integral, and eliminating a between z and derivative of z with respect to derivative of a is equal to 0, we get the general integral. In case of singular integral, differentiating z partially with respect to differentiating z with partially with respect to c and equating to 0, we get 0 equal to 1, which is an absurd result. Hence there is no singular integral. Hence there is no singular integral. I have discussed standard 1. Now I am going to discuss standard 2. The partial differential equation of the form I will discuss in next video. Thank you. If you like this video, please like and share my channel with your friends, and don't be forget to subscribe my channel for next upcoming videos. Subscribe, like and share, and always keep smiling.